Okay, am I audible over here? Yes, over the web. Am I audible over the web? Yeah, wonderful. So we will try to find out answers for at least 3 of these 4 questions. First thing is, what is Kubernetes? All right, and why do we need Kubernetes at all? How does it work? Right, and how does it help in our cases whenever we are speaking about Docker containers? All right, so these are the 4 questions, and remember, Kubernetes is the most happening orchestration, Docker orchestration tool apart from every other tool. Right, there are many, there are hell lot of stuff. Even in Docker we have one thing called as swarm, which we have like slightly seen to basically establish the multi-host networking stuff. In the last class we have tried, even that is one of the orchestration stuff, but it is this is most widely used and most widely accepted stuff. All right, so Kubernetes is, if you know Kubernetes and if you know Docker very well, that is more than enough for you to get a job. So that is how much important this concept is. So no matter whatever technology your company is developing, let it be any technology, all right, if they want to go with microservices, the obvious choice is Docker and Kubernetes. Right, so generally whenever you take a stat of last 10 jobs, more than 50% will be just on Docker. Right, where Docker is a primary skill. I'm not saying Docker is the only skill. Docker is a primary skill. They would also ask about rest of the stuff, but this is a very important stuff which we are going to discuss. Right, so generally normally it will be 3 or 4 days when we take. It is 3 maximum. 3 days is when we try to discuss on Docker, but this time I wanted the stuff to be slightly different. Right, this time I'm taking approximately a week for this. So where initial 2 or 3 days will be the same, we discuss on the concepts, and then at the end we will try to simulate one scenario, one open source application with Kubernetes. We do end to end stuff. Right, for the once you learn continuous integration, the only thing which you have to do to make it a pipeline is call this stuff from Jenkins. నేను క్లాస్లో ఏమైతే చేస్తున్నానో దాన్ని జెన్కిన్స్ నుండి కాల్ చేస్తే దట్ ఈస్ అ ఫుల్ పైప్ లైన్, దట్ ఈస్ అ ఫుల్ స్టఫ్. Right, someone asked me in some of the forum questions saying that how do I get game of life war? Right, so for that you have to build the game of life code if you know it. If not, I think I have published already the container. Get inside that container and you will get a war file. Then the container would publish chesam kada. At the last of the class when I said docker push and I have given Sheikh Khaja Ibrahim / game of life, you go to the Docker hub, search for that, pull it, you will get the war file in that. All right, okay, and then if you create a volume mapping, that war file will be present on your system. Okay, try it in that way. I could have uploaded the war file somewhere and asked you to use that, but I'm asking this way because this way will help you to understand the volume mapping which you have spoken last time. Okay, so if you want to get the war file, what is that you would do? Docker pull Sheikh Khaja Ibrahim / game of life :1.0 or whatever tag which we have published. Right, and -v user local tomcat to and some of your folder, that is, so let us assume that you are running on a Ubuntu machine, then you would say home/ubuntu/mydir. Right, or you just say -volume, just -v and give user local tomcat, and then you give docker inspect and the container's name. It will give you a path. Go inside that path, you will find a web apps directory, and in that you will be anyway find the game of life for, right? Quite a lengthy process, but I want you to do that because this will help you in doing some of the Docker commands, right? Okay, so what is Kubernetes and why we use all of this? So I'll come down to a question. Can we run our entire application in one and only one Docker container? మీ అప్లికేషన్ మొత్తం ఒకే డాకర్ కంటైనర్ లో రన్ చేయొచ్చా? ఇఫ్ ద ఆన్సర్ ఈజ్ yes, you don't need Kubernetes, right? Kubernetes comes into play not for single containers. It comes into play when you want to speak with multi containers. Let it be multiple in many ways. Okay, when I say multiple, it could be I don't want single point of failure. What do I mean by that? So for example, I have only one server where your website is working, and that in that web server some hard disk has gone bad. So will your website still work? No. Okay, so anything happens to your server, your application is going to die. That is the single point of failure, right? So now the first stuff which I want to do is I want to just avoid single point of failure. When I say single point of failure, how do I avoid this? You'll avoid this by redundancy. What is redundancy? You will have more than one server. So two servers, same application being hosted at two servers. Now what would happen? Even if one dies, you still have the other one working. Even if you want to do this kind of stuff, if your entire application is still one container, but for high availability, you can still use this stuff, right? Because otherwise you have to execute by Docker run commands manually, which doesn't make much of sense, right? Or the other case is application broken down into multiple self-executing services. What is this multiple self-executing services? What is the technical name for this? Okay, then Docker and Kubernetes are right thing to be done. Okay, so these are the two scenarios. One is, even though you have only one application, one container, but you don't want that one container to have a single point of failure. You want to have it at multiple places. Kubernetes is the best way or easiest way to do it. In the same way, your application is broken down into multiple services, right? Multiple microservices. So how do you enable communication between them, and how do you scale them and deploy them independently? How do you scale them and deploy them independently? The answer for that is again Kubernetes. So are we setting the context right? Till yesterday, our focus was only on building image containers. When I listed down what are the major tasks of DevOps engineer on Docker, I said that first is containerization. We have learned that now, so we know how to write Docker files, right? At least for the people who have tried it. Okay, so and the next step is, once you have Docker files, you have to make them work, and you have to make them work at different places, okay, at any scale. Okay, on an e-commerce application from 5 to 7, okay, there is no need for you to bring up many servers. The only thing which you can do is you can bring up many containers of sales services. You don't need registration services then. Avuna? 5 to 7, let us assume that Amazon is running some offers will be more for registered users or logged in users, not really for, no one will look at offer and do registration at this point after 4 or 5, after 10 years of Amazon's journey, or 10 or 5 years of Amazon's journey, right? So we will have more sales services, so you can scale them independently. Parts of your application you can scale, which is possible by this word. Making all sense now? We don't speak about single containers now, we speak about multi containers. When I am speaking about multiple containers could be anyway. One is same application redundancy, that should be also possible. And the other one is application broken down into multiple parts and all parts speaking with each other, and you able to increase parts of your application or scale parts of your application, scale services of your application. That's the whole point. At these cases is where Kubernetes comes in. Okay, and it will give some of its features. So for example, how does Kubernetes work? So how do I manage Kubernetes once I have these Docker images? That's what our journey would be. Okay, fine. And remember, Kubernetes is a container orchestration engine. If I have to define a Kubernetes is container orchestration, right? So, and whenever I speak of container orchestration, the definition is container orchestration, not Docker orchestration. Okay, Kubernetes supports two kinds of containers. One is Docker containers, the other one is Rocket containers, right? Rocket is out of syllabus for us, but Rocket is one container technology which some of the people use, right? So you can use either Docker or Rocket, right? And Kubernetes was designed in such a way that it will work with any container technology. Okay, it was not generally made only for Docker, it was made for any container technology. So going forward, if some other better technology comes than Docker, then you might have that also over here. That's the motive of the Kubernetes. Whereas Swarm is specifically for Docker containers. Swarm is very specific about Docker containers. Okay. And now, when we speak of Kubernetes, Kubernetes can be installed at multiple places. Okay, Kubernetes can be installed. A simple version of Kubernetes can be installed on your laptop. Okay, which we call it as kubelet, a smaller version of Kubernetes. And then you can install it on your servers, physical servers or virtual machines or whatever it is, right? And then you can go to the cloud. Okay, and in cloud there are many ways where you can install it. Okay, these are all installations. But apart from these installations, there are already cloud services. So for example, if you go to the Google Cloud and if you want to use Kubernetes, okay, there is no need for you to install Kubernetes. In Google Cloud, you have to say that just I want Kubernetes. Same thing is supported in Azure. Amazon also has it, but it is not available for general release as of now. It is just preview version of it, right? But if you see the scale, all the three best cloud providers are giving Kubernetes readily available. This can tell you the story. We don't, in all the three providers, we don't have OpenShift. In all the three providers, we don't have Docker Swarm, right? That's how it works. So Swarm or Kubernetes orchestration is supported by almost every cloud provider. Okay, and here what you get is, the only thing which you get is you automatically get Kubernetes installed, right? These cloud providers, what they do is they create some connections with their existing services. So for example, if you want a load balancer, right, for Kubernetes also there are chances that for your services you need load balancer, right? So what Azure or Google Cloud or Amazon will do is they will integrate with their load balancers to this Kubernetes services. You don't need to explicitly configure, right? But if you go with manual installation, you have to configure everything yourself, right? So this is the whole story of it. Yeah. So Kubernetes is always for multi-service environments. It's not for single service. For single service, no need of any Kubernetes stuff, right? So, and scale, you can go as much crazy as you want. Right? Google search works on a technology which is basically, or I would put it in this way, the technology which helps Google search to work. Okay, Kubernetes is inspired from that. So there are some best practices of how your Google search is working. Okay, the underlying technology of orchestration is brought into Kubernetes. So now you can understand how much it can scale. So it can go to crazy numbers. That's the whole point about it. Fine. So scaling, it is a proven technology because Google was using it from ages. Yeah, I'll be showing that in one of the slides. But I want to set the context straight away. It is all about multiple container instances. It is all about production. So for production environments, what is that we would have? We would have many stuff to be worried about. Kubernetes obviously gives you that. Fine. Are we good? Yes. Okay. And to test Kubernetes, you have different environments. For example, if you want to do it on your laptop, you can still do it. Yeah, but you might not have all the features. When you try it on a laptop, you might have certain simulations. But Kubernetes has many ways to install. Many ways to install. So there are approximately 100 different providers who are giving you 100 different ways of installing Kubernetes. Okay, so let us not waste our time into installations. I'm telling you this again, right? If I want to use Kubernetes, first I'll take the minimal installation version, right? I'll do that, and then what I would do is I'd go with cloud services. I'd go with cloud services, right? Since Google Cloud is something which you don't touch, we'll be looking at Azure. Okay, probably in the next batch when Amazon becomes freely available, then we would be looking at Amazon's EKS also. That's the whole point, right? Okay, now let me look at questions if I have. What will be the behavior of union file system if we remove the image while running the container? Can you remove the image while running the container? Try if it is possible. Okay, fine. Orchestration. Okay, everyone knows about orchestra, right? Orchestra తెలియని ఎవరు ఉన్నారా? Okay. Or I am quite sure that you might have seen some movies where there will be some musical band and one person with a black suit in front of that musical band just waving his hands. What is he doing? He's orchestrating. He knows which band or which instrument has to be played after what, so that the audience can listen to the better music. That is orchestration. Okay, that's the whole point. So orchestration is working with multiple different things so that your application is working good. Whenever you're working with multiple, not a single, then we call it as orchestration, right? Yeah. Is it related to ECS? No, not at all. Okay, ECS and EKS have nothing in common. The only thing which they have in common is in both the cases you will have Docker. That's it, right? Yeah. Okay, fine. For the question which was being asked, how what will happen to the union file system if I remove the image for the running container? Docker will never allow you to remove the image for if you have any container associated with it. Even force will fail. Even force will fail because it is not allowed to. You cannot do that. Okay, fine. Any other questions in the room about this? Any general doubts? Then we'll get into specifics. Yes. It doesn't matter for it. It doesn't matter. For the only thing which it needs is the nodes where you are having Kubernetes should be able to ping to each other. Whether it is a hybrid network or it is a full cloud network, Kubernetes will not give it. Yeah. Any other questions? Okay, good. So there is one more. What is the use of ECS? Let us worry when we speak about ECS. Okay. So now I'm focused on Kubernetes. Let me finish this, and then we'll be speaking about ECS. Right? Yeah. Okay. Yeah. Fine. Okay. I think I have the same question. Similarly, same questions. All right. Kubernetes is born in Google. It is written in a language called as Go. All right. It is written in a language called as Go, and it is an open source tool. Right. Yeah. This is its. These are its origins. So Borg is Google's proprietary containerization tool, which they used to use in Google search. And later on, they have made some changes and they have brought in something called as Omega. Now, if you are using Google search, you are using an underlying technology called as Omega. Right? I will not say Kubernetes is Omega, but Kubernetes has taken all the best practices of Omega and Borg. So that's why you see a DNA symbol there. So it's not exactly that, but it has certain DNA of whatever Google search is using. All right. So in Google search, they use these proprietary technologies. They are not open source. They are Google's proprietary technologies. But out of it, okay, some of the better practices for container orchestration has been brought into Kubernetes. Has been brought into Kubernetes. Right. Yeah. Generally, whenever you see K8, yes, we are also speaking about Kubernetes because it is very difficult for you to write Kubernetes every time. Generally, people tend to write it as KATS. All right. Okay. Fine. So this is what it is. It is born in Google. It is open source. It has made open source, and it is donated to something called as Cloud Native Container Foundation. All right. So whenever you see something called as Open Cloud Initiative, Open Container Initiative, Kubernetes is everywhere. Kubernetes is everywhere. All right. Okay. Fine. That is fine. That is all historical details, some history about Kubernetes. But we are interested in this part. Kubernetes, what is Kubernetes and why do we use it? Okay. Do you agree to this? What is scalability? Whenever you want one more stuff, you have to increase, right? And basically, we have started to look at data center as one single computer. For example, how many of you are ever worrying in Azure how many physical servers do they have? Or in Amazon availability zone or in Amazon's data center, how many servers do they have? Do we worry about that anymore? No. For us, it is one unit data center, which is almost like infinite resource. Whatever you ask, you will get it. So we have started to viewing our data center as just one single computer, which has everything, right? And whenever you need, you can scale the instances. So the whole stuff is this brings up many challenges. So let us assume this. Okay. This is something we have done our game of life, right? Let us assume take the game of life's example itself. Now let us assume that in cloud I have taken some n number of machines, right? And in n number of machines I have approximately, okay, some, okay. Let me copy paste for easier stuff. So these are all your game of life containers. I have approximately 20 containers, right? So in some cases, some of the containers might need to speak with each other, right? And in some cases, when the user asks, the request has to go to one of these containers. All right. So let us assume this is all game of life. All right. And you are an user who is outside Kubernetes and you don't know how game of life has been installed. You are least bothered. You are a user of game of life. Right. Whether you will be worried as a user where it is installed? Never. For you, the only thing which you will worry is if I am clicking giving a URL, whether the application is coming up or not. Now, the user accesses or makes the request to it, okay, and your application is running in 20 containers. Which container should respond? That is always a bet, right? Which container should respond? Okay. So let us assume that that is not this case. There are, it is not, rather than having one game of life, you have 3 or 4 containers for game of life, and it is, we had made game of life into microservices. So let us assume this is our first layer. Okay, our request has gone into this, and these are all your middlewares. Now from here to which middleware does it has to go? From there to one more tier, from there to one more tier. How does these stuffs, all of these stuffs happen, right? If you are managing this on your own, imagine how difficult it is. So you are running docker run command for 20 times. That's wonderful. But you have 4 front ends, 4 middleware servers, 4 DB servers. Now when one of the container wants middleware, out of this 4, which one should respond? Again, you have to bring in some concept underlying it. And see what is the complexity of it. You have to, the more the services become, or the more your application is broken down into multiple services, you have to bring in extra components. So for every service, you have to write one more Docker container, which is a load balancer. So you have to do loads and loads of stuff. What will happen if that load balancer goes down, right? And now you want 4 containers that are running with middleware. Suddenly something happens to one containers and they die. So how do you respond? Okay. So all of these activities we are delegating to Kubernetes. ఈ కాంప్లెక్స్ యాక్టివిటీస్ అన్ని కుబర్నెటాస్ చేస్తుంది కాబట్టి కుబర్నెటాస్ కి డెలిగేట్ చేసేస్తుంది. సో హౌ Web server, which is your front end, speaks with the second layer of your system, which is a middleware. We delegate it completely to Kubernetes. Okay. So to make Kubernetes understand, we will learn Kubernetes so that our application can be deployed on Kubernetes and it will work as per our needs. As per our needs. So basically, one important thing which you need to understand is anything which you are managing, for creating 20 containers and establishing the communications or establishing the backups, whatever you call it. So we give everything to Kubernetes. To give it to Kubernetes, we have to learn something about Kubernetes, and that is what our initiatives. That is what our stuff is all about. So Kubernetes will add some more terminologies, will add some more stuff to our learning, right? But the whole point why we do it is because we don't want to manage all of this. As a DevOps engineer, if your responsibility is create 20 containers and manage them, okay, it would be like an electricity job. Transformer goes down, the electricity guys have to come during the night and then fix it. So our job will become something like that. During night, some container fails, you have to wake up and scale it by running docker run command. So we don't want to do all of that. We want someone else to take care of it. And the answer for that is Kubernetes. All right. So the challenges are done. So we have three layers. Our application, let us assume our application is this to make it more clear. Okay. So this is our first layer, second layer, and third layer of our application. All right. So whenever user makes request, he will make a request to this layer, and this layer will make a request to this, and this layer will make a request to this layer, and then it will come down and user will get served. So for example, you are asking how many orders have I processed? It will go to the first layer, and then to the second layer, and then to the third layer. The third layer could be your database, second layer could be your Tomcat or Node.js application, whatever it is, right? And first layer could be web server, whatever it is. Now this you have to manage while scaling. దీన్ని స్కేల్ చేసి మేనేజ్ చేయాలి. See how the complexity increases, right? Yes or no? Yeah. You have, if you have one stuff, it is quite straightforward. If you have one stuff, it is quite straightforward. But let us assume you have 20 web servers, 20 middleware servers, and 20 units which have data. Now from where to where will you make communications? This is the complexity. This is the complexity which we are giving all of this to Kubernetes. ఈ కాంప్లెక్సిటీ దానికి ఇచ్చినప్పుడు దాని కాంప్లెక్సిటీ కొంత మనం తీసుకోవాలి. అదే మనం నేర్చుకునే ప్రయత్నం. Right? How do you tell to Kubernetes to do this? That's the whole point. Right. Now, yeah, this is all compute power. All right. As I said, Kubernetes can manage it no matter how much scale it is. All right. But there is one important distinction. I think I have spoken this terminology while I was speaking about Terraform also. Pets versus cattle. All right. Okay. So what is the distinction? What is the difference between pet and cattle? మీరు ఇంట్లో జంతువుని పెంచుకుంటున్నారు, సంథింగ్ లైక్ cat or dog, right? Something happens to it, you'll become emotional. All right. Now compare that with what you are doing with your servers in office. Your server has gone down, everyone will be rushing some server's name. Every organization will know server by their name and thereby IP address, right? So that server is not working correctly, our services have come down and all of that. So what will be your next job? To somehow fix that server so that it will start working again. Okay, right? So this approach is what we call as pet. Now let us assume cattle. So you have a dairy farm and you have approximately 10,000 cattle with you. One cattle is not feeling well. What will be the impact of that on your day-to-day life? So inka problem aithe ammesi inkodu konukkonni anta. Right? Is that the statement what we make? We will say that okay, sell it off and bring it the new one. Why do you want to have all of that pain? Exactly the same thing. When you go to the container technology like Kubernetes, you will not be treating your containers as pets. So if the container is dead, we will never try to fix it. If the container is dead, we will never try to fix it. We will try to bring one more to solve it problems. But if containers are killing continuously, then we will try to fix it. So for some sporadic failures, we will never worry about it. Right? We will never try to correct it. We will bring one more which can do the job. Exactly, this is the terminology. right? You might not know the servers where your containers are knowing, not required also, because you are treating containers suddenly not like pets, but you are treating like cattle, right? So that's a very important technology and very much required. Fine. Now, one important stuff what we do in Kubernetes is, let us assume you want to send basically a book to one of your friend who stays in US. What are the things which you do? ఒక పుస్తకం పంపించాలండి మీ ఫ్రెండ్కి, ఏం చేస్తారు? Courier. And in the courier, what do you tell? From address to address. Or will you tell that, okay, from your courier shop to the airport, take it in Ola cab, and from there, please use only Air India air flights. I don't want to travel in, I don't want my courier to be traveled in Indigo or any other thing. Drop it down and then take a Uber, give it to my friend. So what is your routine? Yes, Kubernetes also will be telling like what you courier, right? And in the courier, we will be basically telling what is from address, what is to address, or what are the required stuff that we call as manifest. That we call as manifest, and we will have a standard format for that. In that format, we'll be filling what is our container that is being done. We give that form or something like that manifest file to Kubernetes, and it would get the work done. So you can work on Kubernetes if you know how to write these files, even if you don't know how Kubernetes works. That's the whole point, right? And we would be learning how to write that manifest files, and that is the majority of our discussion, right? We will not get into the complexities. We'll get into very simple stuff, but for that you have to learn how to write that manifest files, right? So in Kubernetes, the first job for us is know how to fill a form of courier, right? So just like filling the form of the courier in the courier office, we'll be trying to write a manifest file in Kubernetes, right? Docker uses this shipping container terminology a lot. So మీరు డాకర్ ఇమేజ్ చూసినా ఒక పోర్ట్, వన్ సీ పోర్ట్ అండ్ దెన్ లాట్ ఆఫ్ కంటైనర్స్, you will see all of this image representations, right? So that's why we'll be using this terminology a lot. Fine. Okay, as I said, you write the manifest file, you give it to Kubernetes, sit back and relax. Kubernetes is doing your job, right? Because you will be only telling what do you want, not how do you want it. There is a difference, right? Kubernetes, let us assume that Kubernetes is one of your colleague who has joined in new to your team, but he has worked a long back. He has been working for 10 years in the industry. He knows the stuff. So how do you assign work to him? Will you tell how to do or what to do? ఏం చేయాలో చెప్తారా, ఎలా చేయాలో చెప్తారా, right? If he's a fresher straight away from a college, doesn't know anything, will you tell what has to be done or how it has to be done, right? That's the difference. Kubernetes will never tell how it has to be done. We'll always tell what it has to be done, right? So in Kubernetes, I will tell that I want 3 containers. You will not tell that run docker run command with replicas 3 and all of that. You will not never tell that. You will always tell that I want 3 containers. So your work assignment to Kubernetes is always what do you want, not how do you want it. So that's why it will simplify our work. You have to just tell what do you want. That's it. All right. Yeah. Okay. Let me scroll down. Yeah, I think Kubernetes has moved very fast. I'll not say he is moving very fast. It is already reached to the top, right? Fine. Let us look at Kubernetes architecture. This is where the fun starts. Okay, football season, and this slide makes sense now. Actually, I've been using this slide from way back, but yeah. So let us assume this is a football ground, right? Now you will have different players. You'll have different players, right? So how do you arrange them on the field? Will there be certain order? Yes, or any order is fine. ఎక్కడ అక్కడ నుంచోండి, మొత్తం గ్రౌండ్ అంతా మందే కదా అంట. లేదంటే గోల్గా అడ్డుగా పడుకోండి 11 మంది ఎలాగో గోల్ కొడతాం కుదరదంటాం. విల్ నాట్ డూ దట్, రైట్? Fine. So you'll have a team, and then this team will not be in a particular order, but you will arrange them in some order, right? You will arrange that you should have two forwards and then one center, right? All of the defense you will arrange it. Who does all of that work? Coach or a manager, whoever you call it. Exactly, in the Kubernetes also we'll have a manager. We'll have a manager, someone who basically arranges all of this stuff, right? And the individual player is nothing but your Docker container. Individual player is nothing but your Docker container. You would tell how it should be, where it should be, how it should respond. Okay, all of that is being told, coached by, or being trained, or being set by someone called as manager or a coach. Exactly, that is the same architecture of Kubernetes, right? So our players are not Ronaldo or Messi, but our players are Apache services or HTTP services or whatever your application is being developed, and we have to arrange them in whatever order that your customer would expect it to be. All right. So Kubernetes does this. Okay. So node is a physical or a server where you can run your Docker containers, and basically we will be running them on certain machines. On which machine, which container has to go, this is decided by manager. This is decided by manager, like how the coach decides on a football field which player should be standing where. Make sense? Right? The arrangement of containers. Okay, here we are not speaking about single machine scenarios. Definitely Kubernetes is not about single machine scenarios. You will be playing with multiple machines, and generally the machines in this kind of architectures are called as nodes. So which container has to go in which node, decided by manager. Simple. So now we have two important things. One is manager, the other one is basically your physical bare metal where you have nodes, and then you have your containers, and then you have your containers which consists of your applications, right? Wonderful. Now this is how the architecture looks like. You will have something called as Kubernetes master and Kubernetes nodes. Master nodes, very simple terminology. Okay, so the courier format or the packaging format or the manifest, whatever you write, you give it to the master. Sit back and relax. Master will do the stuff for you. Master will basically decide, and he will get back all of your nodes with whatever containers which you have asked, right? So remember, master will never host containers. In Swarm it is a different way. In Swarm basically master also does work, manager also does work. Here master is in charge. Okay, football coach will not play football, at least not on the ground, which we are seeing, right? So in the same way here also master he will not do, the only responsibility for him is to get the work done, like a typical Indian managers, right? So they don't work technically, they just get the work done, right? I'm saying Indian managers because American managers are not like that. They will work, right? So but it is an important work. ఇది చాలా కష్టమైన పని. కోడ్ రాయటం కన్నా మేనేజ్ చేయడం కష్టం. పొద్దున్న అయితే జ్వరం ఉంది, జలుబు ఉందని 10 మంది ఫోన్ చేస్తారు, right? It is very difficult to manage timelines. Yeah, it is a very concrete job, but master is exactly that. He will not do any work, but he will get the work done. He'll get the work done. Now you are seeing three masters, right, in that image. That is just to have high availability. If one master is also on some physical server or some virtual machine, what will happen if that virtual machine goes down? So we will have a high availability masters. We'll have redundancy, right? And then you would have nodes. How many nodes you can have? No limit. Okay, the only limit is your computation power for your application which you want to give. That's it. There are no hard cut limits, right? And on these nodes you will have your containers which will be running. Fine. So you have two and two have died, then it's fine. Yes, three and all the three died, then we have to just pray to God. Yeah. Okay, so master will have some components, right? So we'll get into those components, right? And then we'll be discussing about master. But one thing to remember, right? Here the nodes, were earlier called as minions. If anyone watches cartoon movies, right, I'm sure you might have understood what a minion is. మిగతా వాళ్ళు అసలు మొత్తం యాక్షన్ మూవీసేనా? Right. So I know for me that terminology was good, but I'm not sure why these guys have changed this to a node again. So these are minions, by the way. I'm quite sure you might have looked at it at least once. All right. When Kubernetes started, they used to use this terminology, but somehow now they are acting professional. They are calling it as node and master and all of that. But when they started, node was also called as minion. Right. In some of the documentation, if you are seeing Kubernetes minions, or in interviews, if someone asks as minions, he's speaking about node. All right. Okay. Fine. Let us try to look at individual architectures and understand the components. Right. The most important thing is a coach, football coach now. That we call it as master. And master has 4 components with him. Right. So let us see what they are. Masters. These are the 4 components. And remember, master can be installed only on a Linux machine. Master can be installed only on a Linux machine. Which Linux? Your choice. Whether it is Ubuntu, whether it is Fedora, whether it is Red Hat, your choice. But master works only on Linux environments. Right? That's the first thing. And then you can also have what I said in the earlier case. Rather than having a single point of failure, you would have multiple stuffs. Right. Now, this is basically master don't run user workloads on the master. We generally don't want to run our workloads on the master. We want it to basically get the work done. Right. And then in the nodes, we have something called as pods. Here we don't have containers. We call it as pods. In the Docker, the smaller thing which you can create is a Docker container. In the Kubernetes, the smaller thing which you can create is a pod. Right? And pod is not a Docker container. Remember that. Pod is not equal to Docker container. Right? So using Kubernetes, what is that we create? Pods. Right? Because of this pod terminology, Kubernetes can work with multiple container technologies. Pod ఉంది కాబట్టి Kubernetes multiple container technologies తో work చేయగలదు. I said that, right? There are 2 kinds of containers which Kubernetes can work. One is Rocket, the other one is Docker. It is possible because Kubernetes is not creating either Rocket containers or it is not creating Docker containers. It creates something called as pods on your nodes. Pods will consist Docker containers. So the smallest unit which Kubernetes creates is a pod, not a Docker container. గుర్తుపెట్టుకో. So we'll come back to what that pod is. All right. Pod will contain your Docker container. I can at least you can look in this symbol and you can easily make out. In the pod you are seeing your containers. All right. But Kubernetes, what is the smallest thing which it creates? Pod. And pods are always on nodes, never on master. Pods are always on nodes and never on master. Right. Let us see the components. The first component and a very important component of your master is Kube API server. Kube API server. So we are writing the manifest and we are giving the manifest, right? Courier format lo mana rasi Kubernetes ki istamannam. We write in the courier format and we give it to the Kubernetes. The component which accepts that is Kube API server. So it is responsible for the communication from the external world. Okay. Any request which you make, basically you will be accepting or giving it to the API server. So this is the interface. This is the interface for which accepts communications. So you can access Kube API server from command line or from APIs, REST APIs, right? Anything that makes sense to you. But during our discussions, we will be using command line, right? But if you want to control it programmatically, you can still use your programming language and call it from APIs, right? Then we have something called as cluster store. Cluster store is memory of your master. Whatever you do, right, all of the stuff is stored in this. If you remove cluster store, Kubernetes master will forget everything. What are the different number of pods that are running, whatever are the different numbers of high available setups which I have done, everything it will forget. Okay, so anything that is happening on Kubernetes is stored in clusters, and cluster store is key value storage. Remember, few days back I have drawn a hash diagram and then a value, so you would have a key value pairs. So cluster store is a key value store, and to be very specific, it uses HCD. What is the component which Kubernetes uses is HCD. Okay, HCD is one distributed key value store, one software which does that, so it uses that. So two components, API manager and cluster store. API manager accepts inputs from the users and gets back with the communication to the users, so an interface for external communication. Whereas cluster store is memory. Anything which is happening on this Kubernetes cluster is maintained or stored in. Okay, so whenever you are making high available setups, there will be replication from this cluster store to the other cluster store. మీరు ఇంకొక Kubernetes ని మాస్టర్ చేయాలనుకుంటే, the first thing which you need is memory, and that is achieved by replicating this cluster store with the other cluster store, right? If that is not present, the other new master will not know, new manager will not know anything about what was happened or what is present, right? Fine. So that's why we also call it a single source of truth. In Kubernetes, any state is basically maintained over here, right? Kube control manager. Okay, fine. So in Kubernetes, whenever you write the courier format, you would tell that I want 3 pods with game of life. You would write something like this: I want 3 pods with game of life. And basically, this component of your controller, this component of your Kubernetes is responsible for maintaining that number 3. Okay, so basically you will have multiple types of controllers, node controllers, endpoints controller, and all of that. So what this kube control manager does is it always tries to check whether the state is maintained or not. So for example, you said that I want 3 pods, somehow one pod was killed. Okay, this guy will ensure that 1 is killed right now, so I have to bring in one more. Meer replicas 3 annaru. Okay, 3 will be created. Who is responsible for making it 3? Controller manager. All right, it always watches for the state. State should match whatever the user has asked in his manifest file, should be always present in the containers. That's the responsibility of this kube controller manager, right? Kube scheduler. Whenever you have to create a new pod, right, kube controller manager will tell to kube scheduler and it would get the job done. So we have 4 components. So let us have a look at it again. API server. Why we use this? This is an interface. We speak with API server. Whenever you are basically typing any commands into Kubernetes, this is the only component which is visible to you and me. Right? So we will speak with this. And anything which it has to, everything that is happening on the Kubernetes is stored in a database sort of stuff, which is called as cluster store. And cluster store is key value storage. Okay, it will have key and its value. All right. So it is the memory of your Kubernetes cluster. If you lose this at this cluster store, it forgets everything. It will not know who its nodes are. It will not know on the nodes what are the pods that are running and everything. All right. So, and then the controller manager. Controller manager is responsible for maintaining the state. All right. So whenever the state goes wrong, what it does is it will make an update to the cluster store saying that okay, the count which user asked as 3 and now the current count is 2. Okay, so whenever the current count is 2, then API, then basically your scheduler will come into play saying that okay, I need to create one more pod, let me do its job. So whenever you want to create anything new, you'll be working with scheduler. So 4 components clear. What are the 4 components now? API manager, cluster store, controller manager, and then scheduler. Right, these 4 will make our life very much easier. As on today, all of these 4 components are present in the same master. All right, but there are some discussions in Google where they don't want all of the 4 in the same master and they want to spread it out. So in the future we might see the architectural changes over here. We still have these 4 components, but the 4 components might not be present on the same master. All right, So just to make it highly available, just to make it a non-single point of failure kind of a mechanism. But as of now, this is the architecture, right? Okay. So this is for us, even though we have 4 components, we'll be speaking with the API server and we can call only API server as a master, right? Okay. So what is that you would do? You would write a command, which is basically, to be very specific, it is kubectl commands, and you will pass your manifest file, okay, which is in JSON or YAML format. You upload it to the API server, right? And API server will get the job done by creating some pods on your nodes. By creating some pods on your nodes. Simple. So in a Kubernetes architecturally, we have 2 kinds of machines. One is master, the other one is node. So what is a master? A virtual machine. In AWS, if I have created 10 virtual machines, 10 EC2 machines, I can mark 2 machines as masters and 8 machines as nodes. So master will have 4 components. What are they? API server. API server is a component which you and me use, basically get to speak with, right? And apart from that, we will have cluster store, which is memory, and then scheduler, which is responsible for creating new parts, and then we would have controller manager, which is responsible for maintaining the state. Because in the JSON file which we are writing, we will tell that you will tell what is the state which you want. Remember, I said that in Kubernetes, if it is a 10 years experienced guy, you will not tell him how to do it. You will tell him what is that you want. You will tell him what is that want. So what is that you want is maintained by controller. What is that you want is maintained by controller manager. That's the whole point, right? Now, nodes. Nodes were also called as minions earlier, but unfortunately they are called now not calling it as minions, right? On a personal note, I would like to call it as a minion itself, right? Here we have the same stuff. Kubernetes nodes are also on Linux, are also on Linux. And now over here, which Linux? Any Linux, right? You can use Ubuntu, you can use Red Hat, you can use any flavor of it, right? So here you'll have 3 components. Here you'll have 3 components. Let us see what these 3 components are. One is kubelet, right? So kubelet is the major Kubernetes agent, right? So this is the agent which receives communication from the master, right? So whenever basically you create a Kubernetes node, this is the first component that gets registered. And whenever your master wants to speak with the nodes, it will always speak with kubelet, right? So basically, whenever you want to instantiate the pod, the instruction will be sent to the kubelet, right? And kubelet does the rest. And kubelet does the rest. So if master is the sending stuff, this is the receiving stuff. Make sense? This is the agent. It basically runs every time. It waits for the communication to be received, right? It has certain port numbers. I'm not interested in that. I've just written for the documentation purposes. But if I had to go with port numbers, I will always Google it. I don't remember ports. All right? Okay. The next one, container engine. Okay. So this is how Kubernetes is different. Here you can either install Docker or Rocket. So our Docker installation will go here on the node. So here we will have a container engine called as Docker. So whenever we have container engine called as Docker, our pods can have Docker containers. All right. So here it is container engine. Remember, it is not Docker engine. Here it is container engine. So basically, it has been designed in such a way that tomorrow, even if a new technology comes into play, Kubernetes should still work. Kubernetes should still work. If you see, this is the only component where we install Docker. Rest of all of the things have nothing to do with Docker. Are we good? Yes? Okay. And the last and the most important thing is kube proxy. Kube proxy. And kube proxy is networking for your client. Pod networking. Right? It is responsible for networking. And remember, every pod gets one IP address. Every pod gets. Remember yesterday when we were creating containers, every container got one IP address. Yes or no? Yes. Whenever we created our bridge network, right? And in the bridge network, I have created two containers called as C1 and C2. And then if we have inspected into that, we have seen two IP addresses. Here, a pod gets basically one IP address. Remember, pod is not container. A pod can have multi containers also. So even in that case, pod will still have one IP address. All right, fine. So let us look at these components again. So kubelet agent, which receives the communication, right? And then the container engine, the container technology which you want to use. In our case, we'll be using Docker, right? And then kube proxy, a networking. Basically, this is used for networking. Here you will get the pods networking, right? And the basic communication. How do you communicate with the pods? Everything is basically done over here, right? Fine. Does it make sense now? So we have 4 at master and 3 at nodes. Okay, and remember, you have to basically understand what each component of it does, right? This is not very important basically for what do you say, interviews might not go or might be here, but certifications will definitely be here. Tomorrow if you want to go ahead and write your Kubernetes certification exam by any chance, you should know what every component does, and unfortunately you have to remember every port also. For certification exams you have to remember port numbers also. Okay, fine. Okay, now before going to this part, let me just look at the questions which I have till now. Rocket is one more container. Then we have LXCs and LXDs, right? LXC is Linux traditional container which you can basically create. Kubernetes does call by Jenkins. That could be your delivery pipeline. Kubernetes can be called from your Jenkins. Okay, so Kubernetes master, what does it expect? A JSON file or a YAML file. All right. If Jenkins is speaking with Kubernetes API manager, will it not respond? It will. That's the whole architecture. All right. So it could be, I'm not saying it is the only architecture, because every company has its own organizational decisions. But in your resumes, you can tell that we build the code, right? We build the Docker image out of it, and then whenever we want to push it to our production environments, whenever you tell to your in the interview saying that my environment is completely Docker, then you can say that we will have one more step where we will do our deployment or delivery, whatever you call it, by basically pushing the manifest to Kube API manager, and it would ensure the stuff is done. That's it. All right. Yeah. How to know the IP address of the container before creating it? You cannot know it. You cannot know it. Right. But if you are speaking about container networks, you can easily predict, because container networks, whenever you create your bridge network, right, it is very easy to know, because you know what is the last container is running, add one to it. That's how it is not a very complicated algorithm. If the current container's IP address is 10.10.10.1, whenever you create a next container, the IP address would be 10.10.10.2. But there is no need for you to know the IP address before you create. There is no point in that. All right. Yeah. Does Kubernetes call Docker run command to create Docker containers? Obviously, it has to call Docker run, right? Docker ni Kubernetes call chesina, ever call chesina Docker run command tone call cheyali, right? But when we come to this Kubernetes, we will not worry how Kubernetes is calling Docker. We will be just worrying whether my application is running or not. Yes. Okay. What is REST API? We'll discuss it at the later point of time. Cluster store. Cluster store is the memory of your Kubernetes, right? So it is, if it is short-term memory, it would be like Gajini movie, right? So it is not that case. It is a very sharp stuff. Everything is in that cluster store. How many nodes are attached to this master cluster store? Everything which you want to know about basically your cluster, you will always speak with cluster store. And cluster store is nothing but, it is called as key value store, distributed key value store, right? And distributed key value store, the application which it uses is HCD. Okay, HCD is one application which can basically can be used for storing key value pairs. All right, fine. Cluster store info will be saved in some database in real time. Real time Kubernetes will not do anything extra. It will still store in cluster store. All right. The only thing which you do in real time is you will take a backup of it. which you and we will not do it right now. And మనం చేసేటప్పుడు పెద్దగా బ్యాకప్లు తీసుకోం. But if it is real time, the cluster stores backup is taken periodically, because when, if by chance if your Kubernetes goes down, okay, you can bring up the Kubernetes, but memory, if you have to bring in feed in, then it is cluster store. All right. Okay. Is API similar to AWS API gateway? No. API server has nothing to do with AWS API gateway. No. All right. API server is a way of exposing, okay, or way of giving a way for you to speak with. So I would tell, if laptop was my manager, keyboard and mouse is my API manager, because it allows me to speak with my laptop, right? Just think of it as an interface, right? And whenever we are giving an interface, there are multiple ways, right? One is keyboard, the other one is touch screen, same way. So Kubernetes gives you a command line CLI version and also an API version, which your programming languages, or from HTTP you can make calls. That's the difference. All right. Okay. What is the use of pod? It is not use of the pod. What does pod does is important. There is nothing called as use of pod over here. ఎందుకంటే డాకర్ లో కుబర్నెటస్ లో పాడే క్రియేట్ అవుద్ది, మీకు నచ్చినా నచ్చకపోయినా. సో పాడ్ ఇస్ an environment where your containers are run, right? Pod is the smallest thing which your Kubernetes can create. In the case of Docker, the smallest thing which Docker used to create was a Docker container, right? In the case of VM, the smallest thing which VM can create is a virtual machine, right? In the case of Kubernetes, the smallest thing that Kubernetes can create is a pod. Pod will consist of your Docker container. Pod lo me container untum. Okay. So there is nothing called as what is use of pod. Everything is pod here, right? Fine. So pod is your execution environment. Fine. In the case of Docker, job is less while we are using Kubernetes. I didn't got your question, but why my job suddenly becomes less? I don't think so. Okay. Job is less in terms of orchestration. Okay. If you are doing everything by yourself by executing commands, it would have been much difficult. In Kubernetes, it would make your life simpler, because you are just writing manifests and giving it to your API server. In that way, it is simple. In that way, it is simple, right? Okay. So cluster store info will be saved in some data. No, cluster store itself is a database. It uses a component called as HCD. HCD is a distributed key value store software, right? So that's where it is. In real time, there is no change, right? Fine. Any other questions in the room? Yes. Hmm. Oh, is it? So what is the responsibility of Kube Control Manager? Okay. To maintain what? State. In the state, what is that you are trying to tell? That's all. That's all. See, let us basically simply tell. You said that I want 3 pods. Okay. To whom you will tell? API manager. And API manager will do what? He will try to store it in the cluster store. That's the first job, because it's a memory. Now, once you said that you want 3, okay, then there is one component which was called as scheduler. And what is the responsibility of the scheduler? Creating new pods. So it creates 3 new pods. And then the responsibility comes to what? Controller manager to see whether 3 pods are running or not. Okay. So this controller manager might be termed as advisor in your case, because whenever that 3 becomes 2 by any chance, whenever you want to scale, then what it does is this Kube Control Manager will basically make an update in the cluster store saying that the desired state was 3, but the actual state is just 2. Then the pod comes into play. Yeah. So what is scaling? What is scaling? Just tell me. Okay. In the scaling, what will you tell? Whatever it is. What is the number which you will tell? So మీరు చాలా ఎక్కువ ఆలోచిస్తున్నారు. స్కేలింగ్ అంటే ఇప్పుడు నాకు 10 ఉన్నాయి, నాకు 15 కంటైనర్లు కావాలంటారు, అంతేనా? ఈజ్ దట్? At the end of the day, is that the case or not? Yes or no? Yeah, whatever it is. So you have 10 VMs running right now. In the scaling, what will you tell? You want either 15 or 5, right? Whatever it is. So where the same process will happen again. So your manifest has been changed from 10 to 15. Entry will go into cluster store. Cluster store will basically give the responsibility to the scheduler to create 5 more pods, and then the state will be maintained. This is a cycle. Okay. So load is a different thing. So don't bring in load here. Load is some other thing. Load I have not spoken about it. See, yeah, absolutely, absolutely. So an external component which decides how much the load has to be in, that is your cloud components, not Kubernetes components. You got the point, right? So for Kubernetes, it notes only 4 things. You just tell me what is the state, I'll maintain it. So whenever you are increasing the load also, for example, there are 10 pods. Now you want 5. So again, you will update in the cluster manager. Then it would go and speak with, it will be updated to the controller manager, will find out that you wanted 5, but actually there are 10 running. Okay, let me destroy 5. So that's how this stuff works. This is a chain. What is the count that has to be maintained is an external component, not these 4 components. That's a difference, right? Yeah. Okay. Is it making sense? Here, everything in Kubernetes is what you ask to do is what you get, right? Fine. So you want 5 or 50, it doesn't matter. There are components which will help you to get it done. All right. So one is at the master component, the other one is very important is the pod stuff. Pod stuff. All right. So let me see. I think I have 3 minutes of time. I'll not be able to cater this. But okay, let us start this declarative model tomorrow and let us see what is that we will tell in Kubernetes. In Kubernetes, what you will tell is you will always tell what do you want. So that is what these next section of slides are all about. All right. And once we know how to tell the basic stuff, then we will be going into something called as services and deployments. Services and deployments, right? And then at the last, we will be integrating this with cloud providers. Then we will speak about load balancing. Then we will speak about load balancing. There we need an external component which speaks with API manager to get the stuff done. That is your advisor. And advisor, there are different versions of advisor. For example, Azure has its own advisor to get this job done. AWS has its own advisor. It is an external component, right? But the only component that will ensure your state is maintained are 4, whatever I have spoken about, and 3 components. And you should be able to illustrate the meanings or the purposes of all these 7 components. ఇవాళ మనం మాట్లాడుకున్న 7 components ఏంటి? API manager. What is the responsibility of it? It's an interface for getting communicated, right? Cluster store, store everything there. Everything what that is happening on your Kubernetes cluster is stored in cluster store. And then controller scheduler. It basically, it is like a watchdog timer. It always basically checks for all the nodes whether the count is being maintained or state is being maintained. And then we have scheduler. Scheduler is responsible for creating or deleting whatever it is to maintain the pod stuff, right? These 4 components form something called as master. And when we go into the nodes or minions, there we have kubelet. Kubelet is an agent. Okay. Kubelet receives communication from your master saying that create a new pod or delete the pod. Okay. Anything and everything that has to do with controlling, kubelet will receive stuff. Okay. And remember, kubelet will not make any decisions. Kubelet is a dumb component. What it does is it will just report the status. Whatever manager tells, it will try to do. It will not use its brain in any case because it will not have a brain, right? And then we will have a container engine. Container engine is your actual installation of Docker or whatever technology which you are trying to make it work, right? And then we will have something called as kube proxy, which is a networking component for orchestration. So because whenever you create, yesterday while I was explaining this, I have drawn 20 containers and they have to speak with each other. Okay. So kube proxy is a component which maintains that networking, right? 7 components. And then the smallest thing which Kubernetes can create is called as pod. Okay. And the Docker containers which you created will be inside this pod. Not they are not, pod is not equal to container. Remember that. Pod consists of container. All right. Fine. So are we good on all of these terms? Yeah. So tomorrow we will try to understand the rest of the aspects of this. right? We will understand service and deployment. Remember, if you are able to do deployment on Kubernetes, there is nothing like that. Okay, fine. Okay, let me look at one last question if I can. How load balancing works when it is scalable? Load balancing, how it works? So I am not getting what is load balancing. First of all, you have more than one stuff which is being done, right? Yeah. So for example, if you have 3 pods and suddenly they become 5, so the question is, how do I basically uh, send the traffic, or basically distribute the traffic? So whenever 3 becomes 5, where is that all of that information being stored? Cluster storage. So do we have a place where we can get all the pods IP addresses? Yes. So that's the logic to make it work. So in Kubernetes, the memory is cluster store. Everything is stored in a cluster store. Okay. And then we will have anyway kube proxy component, which deals with networking. Okay. You will add a load balancer to the kube proxy to get the work done. As simple as that. Kube load balancer information account the cluster store because cluster store remembers everything. It knows everything. That's the whole point. Fine. As the DevOps engineer, what is your role with respect to Kubernetes? I said that you have to orchestrate your applications architecture. You have to deploy in Kubernetes and get it work, or you have to maintain this cluster. That's your responsibility. All right. And generally we do it from CLI and also from APIs. In our throughout our class, I will not be speaking about any APIs because I have to use any programming language to speak with that APIs. My whole Kubernetes journey will be via CLI itself, command line interface, and then cloud providers like Azure. All right. Fine. kubectl and kubeproxy installed when node adds to the Kubernetes cluster. We'll look into that because we'll be installing this. Okay. So don't worry about those aspects. Worry about the 7 aspects which I have said. Right. 7 and pod. Right. Tomorrow we'll be going one level deeper into this. We'll be understanding the rest of the aspects, and then we'll install one Kubernetes cluster, and then we'll try to make simple stuff, and then we'll take a real-time example of some application which has all the layers, and then we'll try to deploy it on the Kubernetes cluster. All right. Okay. Last question. Above. What is above? ఎక్కడ అడిగారండి మీరు మళ్ళీ కాపీ చేస్తే ఈజీ సార్ నాకు అది does Kubernetes call? I think in the case of, oh man, just creating Docker file should be enough. No, it's not that easy to, right? Because you have to write your manifest file. Docker file is something which you write for your image, but to speak with Kubernetes, you have to write manifest file, the courier format which I have said that you need to write, you need to fill in. So we'll have to build an image, and also we'll have to write a manifest file. That's our responsibility. Yes. In what case Docker job is less? In that case, Docker job is less while we are using Kubernetes. I'll not say it is not less, man. It is not less. It is still the same. But the only thing is, you need not do lot of stuff when you do. For example, if I ask you to create 3 different servers and then try to create 20 containers in 3 machines and make it work, then you will be doing lot of jobs which you are giving it to Kubernetes. All right. Only in that case, Docker job is less in Kubernetes. But rest of the things don't get down. Your application, you have to still write a Docker file, right? You have to still write a Kubernetes manifest, right? So your work is not going to be reduced. Yeah, your work is, I'll not say work is reduced, I'll say work is simplified. There is a difference between reduction and simplification, right? So here the concept is, it is simplification. It is simplification. We still have to maintain this cluster. That is a huge stuff to be done, right? So we'll meet tomorrow and discuss further on rest of the aspects of Kubernetes. Okay. My tomorrow slide and whatever I'm going to discuss in Kubernetes is already present over there. Okay. If you want, you can go through it. Those are visual and they don't need much technical knowledge to understand, and they are already present in the blog. So if you want, you can go through that. Okay, fine. Then we'll meet tomorrow to discuss the rest of the aspects. Thanks. Yes, this manifest will be put in version control systems so that we can deploy this environment again and again. Yeah.